Today's learning target is I can write and evaluate expressions using negative exponents.
So in the past lessons, we've been talking about exponents. Today we're going to talk about negative exponents. Let's take a look at how these negative exponents work here. So here we have a chart that shows us 10 to some different powers. So 10 to the third power would look like this written out, and that would be 1,000. 10 to the second power, 10 times 10 is 100. 10 to the first power, it's just 10, and 10 to the 0 power, we talked about that last lesson, is 1. Now take a look at the relationship between the exponents and what it equals. So 10 to the third power, there's 3 tens that we're timesing. 10 to the second power, it's 2 tens we're timing. Each time we go down one exponent, we're just dividing it by 10, right? We're dividing by 10, dividing by 10, dividing by 10. Now that brings us to right here, 1. Now if I divide 1 by 10, I get 1/10, which I can write like this. But I can also write 1/10, we know, like this. So 10 to the negative first power is really 1/10. It doesn't have to do with negative numbers, and that confuses people sometimes. So what the negative exponent tells us is that that number is going to be somewhere between 0 and 1. So another way to write this, 10 to the negative second power, would look like this. 1 over 10 times 10, which we know would be the same as 1 over 100, so 1/100th. I could also write it like this. So 10 to the negative third power could be written like this, 1 over 10 times 10 times 10, which would be 1 over 1,000, or 1/1000ths. So the negative exponent here doesn't mean it's a negative number. It tells us we're going to be dealing with a fraction, a number between 0 and 1. Let's take a look now at how we can write these two expressions here using positive exponents. So let's start with this one, 2 to the negative third power. So we know that 2 to the third power would look like this, 2 times 2 times 2. So if we take a look at 2 to the negative third power, we know that that means that we're dealing with a number that's going to be in between 0 and 1. So it's going to be 1 over 2 times 2 times 2, okay, which we could say 1 over 2 to the third power, or if I solved 2 to the third power, it would be 1 over 8. So let's take a look at this one here, m to the negative fourth power. So we know that m to the fourth power would look like this. I'm timesing m by itself 4 times. And we know negative to the negative fourth power would mean 1 over m times m times m times m, which would be the same as 1 over m to the fourth power, just like that. So in these two problems here, I'm being asked to write the expressions using negative exponents, which will be the reverse of what we just did. So 1 over 4 to the second power, or 4 squared, would look like this. And I'm just doing the reverse of what I just did. So I'm dealing with the exponent 4, and there's 2 of them, right? So I'm going to go to the negative second power. Now remember that negative means that I'm dealing with a number between 0 and 1. So that would mean I'd have my fraction here. So 4 to the negative second power would be the same as this. Now if I wanted to write 1/27ths as using a negative exponent, I'd first have to figure out what do I times by itself at least once, or maybe more, to get 27. And I know that 3 times 3 times 3 would give me 27. So to write this one, I'd be looking at 3 to the negative 3 power, because 3 is my base number, and there's going to be 3 of them. So I can also use negative exponents to show very small numbers. So in this case here, we have the number 1/1,000,000th. Now the first thing I want to do when I'm doing this is to figure out what my base number is. In this case, it's 1. Now if it was a 7 here, my base number would be a 7. If it was 0.000023, my base number would be 23. Now think back to the chart that I showed you on the very first slide of this, where we said 10 to the negative 1 power is 1/10, because to the negative 1 power means we divide by 10. So 1/10, we put our decimal right there. 10 to the negative 2 power would be 1/100th. To the negative 3 power would be 1,000th. So in order to figure out what negative exponent I'll use to write this number, I'll have to figure out how many times I'm dividing by 10 in order to turn my base number here into this number. So to do that, I'd start here, divide it by 10 once, twice, 3, 4, 5, 6 times. So this would be written 1 to the negative 6 power. Okay, the last thing we're going to do here is to evaluate this expression right here, which includes a negative exponent. So the first thing I'm going to do, and the first thing you should do when you're solving these problems, is to rewrite this expression, but to fill in any of the variables that we know. So we know a equals negative 2. So I wrote it out right here, 4 times negative 2 to the negative 5th power. So I'm going to use my PEMDAS, my order of operation, in order to figure out what to solve first. So I've got an exponent. That's going to come right here. So I have to figure out negative 2 to the negative 5th power. All right, now, I know this negative 5th power means I'm going to be taking 1 over a negative 2 5 times. So that, right here, this expression will look like this right here, right? The negative to the negative 5th power tells me it's 1 over 5 of these negative 2's. 1, 2, 3, 4, 5. And now I'm going to times that by 4. Okay, so I'm going to times it by 4. And I'm going to put that in fraction form because I'm multiplying fractions essentially here. Now, let's take a look at this. I can do some simplifying before I solve this. I know that a negative 2 and a negative 2, when I times them together, will give me a positive 4. And I know now I can cancel those out, right? Because 4 divided by 4 is 1. And now that leaves me with a negative 2 times a negative 2 is positive 4 times a negative 2, and that gives me negative 8. So in my numerator, I'm left with 1. In my denominator, I'm left with negative 8. And the way to write that, I just put the negative sign to the outside, and it would be negative 1/8, just like that.